Hello students, today we start a new topic in Tacheometric survey, module number 6. So here topic is a fixer method. So in a last lecture we discussed about the two type of the method, fixer method and movable hair method. So in a fixer method hair is fixed, and in a movable hair method hair is movable, and here in a fixer method there are main three cases is there. Case number 1, when the line of sight is horizontal and staff held vertical. It's a case number 1. We discuss in the next slide in a detail regarding all these three cases. And case number 2, when the line of sight is inclined and staff held vertical, considering the angle of elevation is positive, and consider the angle of depression negative theta. So here positive sign show the your angle is your target point is above the horizontal line of sight, and if the angle we write a negative means targeted point below the horizontal line of sight. Now case number 3. Case number 3 is when the line of sight is inclined but staff held normal to the line of sight. Here word indicate the normal to the line of sight means horizontal line of sight and staff both are at a 90 degree with each other. So it's a case number 3. So let's we start a case number 1, when the line of sight is inclined and staff held horizontal and staff held vertical. So here see this figure. In this figure you exactly seen about the 3 crosshair. So here P, Q and R, these are the 3 crosshair point, and these 3 crosshair from the lens, passing from the lens and targeted the point P, Q and R. It's a capital PQR, and here this capital PQR is a staff reading, so here we got the staff intercept S. So here staff intercept is a difference between the P and R value. So top and bottom or upper and lower crosshair reading difference is a staff intercept S, and this is the I is a staff interval. So it's a reading of the difference between the small r and small p is a difference of the staff interval I. Now F is a focal length, then after D is a capital distance between the targeted point or object to instrumentation, then after small d is a distance between the your instrument axis to lens distance, and here x is a horizontal distance from O to staff, and x dash is a horizontal distance from O to plane of heads. And let's we start a triangle. We take a triangle. The rays passing from the POP and QOQ passing through the O are the straight line, and triangle POQ and small POQ are a similar, hence x divided by x dash is equal to S upon I. So how to exactly know POQ? So this triangle, capital triangle, and small POQ, these two triangle. So here x divided by x dash is equal to S divided by I. So it's a simple formula, it's a mathematical formula. Now but x upon x dash are conjugated focal length distance. So focal length f, 1 upon f is equal to 1 upon x dash plus 1 upon x. So now multiplying both the side by fx, so fx divided by f is equal to fx divided by x dash and fx divided by x. So after cutting the value we got the x is equal to x upon x dash into f and plus f. Now x upon x dash, so all of you know about the x upon x dash is equal to S upon I. So put the S upon I in place of the x upon x dash. So x is equal to s upon I f plus f. Now add a c on both the side. So here, sorry, add a d on both the sides. So x plus d is equal to s upon I f plus d. So now x plus d, from the figure you exactly seen that x value plus d value is a capital D value. Clear? So x plus d is equal to capital D, and f upon I into s plus f plus d. F plus d is a constant value c. So we put the constant value c, and we take k is equal to f upon I. So these two value f upon I is equal to k, and f plus d is equal to c, we put in this equation. So we got the final equation, d is equal to ks plus c. Clear? So it's a final horizontal distance find out equation when the line of sight is horizontal and star field vertical. Now vertical distance formula. So where line of sight is horizontal, so vertical distance is always 0. So here no any equation for finding out the vertical distance when the line of sight is horizontal and star field vertical. So here no any type of the equation is there. So vertical distance v is equal to 0. Now we start a case number 2. So in a case number 2, exactly seen when the line of sight is inclined and star field vertical. So line of sight is inclined. So here inclined is divided into two parts, positive and negative. So positive angle is shown the elevation, and negative angle show the depression. So here positive angle, see this positive theta. So here angle is positive. So from the horizontal line of sight to central hair angle is a plus theta, and star field vertically on any point. Now let the instrument set at a point. So here we instrument set at a point. Then after a dash is a position of the instrument axis. So this dotted line show the instrument axis. Then after P is the stop station. So see this point, P point is a stop station. Now DBC, D, B and C, these three are the points where stop cut the heads of the diaphragm. Now angle CA dash K, CA dash K. So CA dash is a central hair, CA dash, and A dash K is a horizontal line of sight, is the inclined of the line of sight A dash C to the horizontal. And now BD, B to D is the staff intercept S. So here B is the bottom reading and D is the top reading. So difference between the B and D is a staff intercept S. Now next is the CP. So here C to P point is a H, small h is the central hair on the axis hair reading. So here see the small h value. So small h is a central hair reading, and A dash C is the L, capital L is the distance along the line of culmination A dash C. Now A dash K is a horizontal distance, capital D is a horizontal distance between the instrument station to stop station P point. Now CK value, this CK value is a vertical distance V from the central hair reading to horizontal line of sight reading. So it's a vertical distance V. See this in figure. Now draw perpendicular line through the C2 line of sight A dash C, so that it is cut the A dash D in a D dash, and A dash B in a B dash. Is the projection of the DB perpendicular to A dash C shown in a figure. Now line BD is perpendicular line BD is perpendicular to the line A dash K and B dash K perpendicular to A dash C. Now we take a triangle DCD dash. So we take this small triangle DCD dash is equal to BCB dash. So this two triangle is there, and both the triangle DA dash C, DA dash C and BA dash C, both the angle is a beta angle is there. Clear? Now A dash D dash C, A dash D dash C is a 90 degree minus beta. So we have already this angle, so 90 degrees that. So this A dash D dash C is a 90 degree minus beta. Now D dash C is a 180 degree minus 90 degree minus beta, because total this line total angle is a 180 degree. So we find out the half angle. So 90 degree minus beta is a minus from the 180. So we got the final answer 90 degree plus beta. So angle B, similarly angle B dash C, same 90 degree minus beta. Now from the triangle S, triangle D dash C and B dash C, D dash C is equal to DC cos theta. So here simply we take a triangle D dash C, this triangle, and B dash C, another small this triangle. So we apply the mathematical formula cos theta and sin theta. So we apply the cos theta is equal to D dash C divided by DC is equal to cos theta. So D dash C is equal to DC cos theta. Similarly B dash C is equal to BC cos theta. Now D dash C plus B dash C is equal to DC cos theta plus BC cos theta. Now D dash plus B dash is equal to D dash C plus B dash C. So cos theta we take a common, DC plus BC cos theta. Now D dash B is equal to DB cos theta, because DC plus BC is a DB cos theta. So D dash B is equal to DB cos theta. Now DB value is a staff intercept S value, so it's a S cos theta. Now horizontal distance D equation is there. So horizontal distance D is equal to F upon I DB plus F plus D. So DB is a staff intercept S. Clear? So here D is equal to F upon I S plus F plus D. So now inclined distance A dash C is equal to L F upon I D dash B dash plus F plus D. So D dash B dash is equal to S cos theta. So now L is equal to F upon I S cos theta F plus D. So here horizontal distance D is equal to L cos theta. So L is inclined line and theta is here. So cos theta is equal to D by L. So D is equal to L cos theta. So put the value of the D in a above equation. So D is equal to L F upon I S cos theta plus F plus D cos theta. So D value, all the entire L value put in a equation number this, and then after we finding out the horizontal distance D value. So D is equal to F upon I S cos square theta, because F upon I S cos theta and cos theta is a cos square theta plus F plus D cos theta. So F upon I, we already known about F upon I is a constant K, and it's a multiplying constant K, and F plus D is a additive constant C. So D is equal to F upon I S cos square theta plus F plus D cos theta. In another word, D is equal to Ks cos square theta plus C cos theta. We put the F upon I is equal to K and F plus D is equal to C in a this equation. So we finding out the horizontal distance. Now vertical distance V. So vertical distance V is equal to L sin theta. So how we get the L sin theta? So vertical distance, theta sin theta is equal to V divided by D. So V is equal to L sin theta. D value, V divided by L is a sin theta. So V is equal to L sin theta. Now put the value of the L in this equation. So f upon I s cos theta plus f plus d is a L value. So enter value put in this equation. V is equal to s cos V is equal to L sin theta. So f upon I s cos theta sin theta plus f plus d sin theta. So f upon I cos sin t theta divided by 2 plus f plus d sin theta. So f upon I is equal to k and f plus d is equal to c. So v is equal to ks sin 2 theta divided by 2 plus c sin theta is a final equation for finding out the vertical distance v. Now elevation of the staff for the angle of elevation. So elevation of a staff is elevation of the instrument. So this horizontal line of sight plus RL of benchmark, plus V minus H. So we finding out the value of the P. So in elevation of the staff we find out the using by equation this. Now elevation of the staff for the angle in depression. So when the angle in depression, so this value positive V in place of the plus V we put the minus V. Vertical distance we put as a minus value. Another equation is same, but only here V value is changed. Now horizontal distance equation is equal to d is equal to f upon I s cos square theta plus f plus d cos theta. In another word, d is equal to ks cos square theta plus c cos theta. Now vertical distance v is equal to ks sin 2 theta divided by 2 plus c sin theta. So these both are the equation for finding out the horizontal distance and vertical distance when the staff held vertical to the line of sight. Now we start a new case number 3, when the line of sight is inclined and staff held normal to the line of sight. So normal to the line of sight means your line of sight and the staff both are 90 degree with each other. So here in the case number 3 there are the two cases there. So here plus theta and minus theta. Plus theta show the elevation and minus theta show the depression of the staff held in a when we staff held in a any point P point. Now horizontal distance formula is d is equal to ks plus c. In another word, d is equal to f upon I s plus f plus d. So d is equal to s cos theta plus h sin theta. So here cos theta is a vertical line and sin theta is this line. So d is equal to horizontal distance d is equal to L cos theta plus h sin theta. So this value we finding out the here inclined line is L and this distance is a V. So we apply the cos theta. So here this value is L cos theta and this value we got the H sin theta. So L cos theta plus H sin theta. So L is equal to Ks plus C cos theta plus H sin theta. So this D and L value is same in this case. So L is equal to Ks plus C cos theta. Now Ks cos theta, C cos theta plus H sin theta. Now similarly vertical distance V is equal to L sin theta. So here horizontal distance D is equal to L cos theta. Similarly vertical distance V is equal to L sin theta. So L is equal to Ks plus C and sin theta is that. So Ks sin theta plus C sin theta. Now elevation of the staff station. So elevation of the staff station is elevation of the instrument means this. plus RL of the benchmark plus vertical distance V minus h cos theta. So here this value is a minus h cos theta. So you already find out. Now consider the angle of depression minus theta. So horizontal distance D formula is equal to D L cos theta minus h sin theta. Here horizontal distance D is equal to L cos theta plus h sin theta, but here in place of the plus we put a minus. If the staff put in a depression angle, so L is equal to L minus L cos theta minus L h sin theta. So Ks plus C cos theta minus h sin theta. So Ks cos theta plus C cos theta minus h sin theta. Similarly, vertical distance is L sin theta. So L is equal to Ks plus C sin theta. So Ks sin theta plus C sin theta. Now elevation of the staff. So elevation of an instrument is equal elevation of the staff is equal to elevation of the instrument plus RL of benchmark. Here in a if the angle is positive, so we put the plus V, but here angle is in depression, so we put here minus V minus h cos theta. Clear? So here all these three cases are completed. Now in the next lecture we discuss about the tangential method. So here we stop our topic. Thank you.